Welcome back guys. So in this video, as I was talking about, we will see that how we can replace this old way of writing runnable into a lambda expression. Okay, so if you look at my next example, let me first write the runnable and let me convert it so that you will get clear understanding of. So what happens usually when we write runnable? Okay, create a reference is equal to, we write new and then runnable. That's how we implement, guys, right? Now let's say I need to convert this into a lambda expressions. Okay, so to convert into the lambda expressions, what I need to do that is, whatever you guys are seeing, that this runnable and this is the parenthesis, right? So what we can do, we can write into a simple way where first line what we'll do, will replace this, okay, with arrow. Okay, the first thing we'll do, will replace with the arrow, and then once we'll replace with the arrow, we don't need this. Okay, that is the first thing. We'll replace with the arrow and we don't need runnable, because by default the type of this lambda expressions is going to be considered as a runnable. Okay, now what we have here is, we have a run method. Okay, we can see that we have a run method. So in run method, what we will do that is, this everything, so whatever you are seeing that till here, so this is going to be surrounded with one more, this is going to surrounded with one more colon. Okay, and remove this override. Okay, remove this override. So basically inside this you don't need to write run method now. Okay, you don't need to write run method. Remove this run method also, guys. Okay, step by step I will explain you so that you will understand. Now inside the run method you want to write some logic. Okay, so let's say I want to write here thread dot slip. Okay, for 1 second. So this guy also will throw interrupted exceptions. Okay, surrounded with try catch. Okay, let's do that. This I'm converting to the lambda expressions. Okay, the first thing. Second thing, now if you look at here, right, this is your runnable now. Okay, you are just writing into a try catch, nothing else, and this is your lambda expressions. Now is it okay if I will remove this? Right, is it okay if I remove this? Yes, it is okay. Do Control A, Control Shift F. Okay, so you can see that the same runnable, this got converted into the lambda expressions. This is the lambda expressions, guys. Okay, and one more thing. So let's say you have multiple line of code. Okay, then only you use this curly braces. Let's say you have only one line of code. Okay, let's say your runnable has one line of code. Let me show you. I just have I am runnable, then I don't need to write semicolon also. If my runnable has only one line of code, I don't have to write. Now how this works is, this particular lambda expressions will be considered as of type runnable. Okay, because here the type is runnable, so I don't need to go and specify that the type of this. Okay, so you can see that how nicely this got converted into a lambda expression. Now copy this lambda expressions. Okay, whatever I have written inside, guys, you can, if you cross check, this is also the same. Whatever I have written here, guys, right, the lambda expressions, it is the same. And guys, my suggestion is, when you are watching this Completable Future, please make sure that you would have watched my all functional interface video which I have designed before that, and all your stream classes, so that you will not get any confusion. That is the reason I always write this line. Okay, if you really want to be a master in that, please watch in the sequence. Now you generated into the lambda expressions. Now I can copy this lambda from here, and I can just go, I can remove all the line and I can paste it here. This also works fine. Okay, this also works fine, guys. There is no problem at all. So you can see that how in my previous example I was using the old way of writing that runnable. Now I have converted into the lambda expressions, and both will do the same job. So here also, if I will run that, so there is no print statement. If I'll do that, it works in the same way. So what I will do here is, in the try, or let's say in this runnable, I am going to print thread dot get, sorry, thread dot, so what we have here, thread dot current thread. Okay, sorry, sometimes it happens. Thread dot current thread dot get name. Okay, and after the try, you just write here I am runnable. Okay, and here the same thread, whatever you have, you just print outside the runnable. Right now, let's say if I will run that, let's see that what will happen. So one is executed by the main thread, and the another one is executed by the common pool worker thread. Okay, that I have already explained the architecture in my previous video. Now one thing what we see here is this guy is not getting printed. Why? Because this piece of code, okay, this runnable is getting executed in the async way, the asynchronous way, which means this is getting executed in the separate thread, this guy is getting executed in the separate thread. Now the problem what will happen here is, when you are running the code in the async, okay, your main thread will not wait for that. Okay, your main thread will not wait for that. If you really want to finish your asynchronous call and you want to consume the output, always you need to call the get. This get will wait for the infinite time. That is another drawback. Okay, this get method will wait for this async, this future, to complete for the infinite time. There is no time. Okay, so this get will wait for the infinite time. Now if I will run that, you can see that everything should get printed. So what happened? Yeah, so you can see that I am runnable, which is getting printed. Why it took some time? Because we have a thread dot sleep here, guys, so it took time, and you can see that everything is getting printed. Right, in next example we'll try to understand some more concept, guys. Okay, so let's see that here. If you try to understand, I have a small method here. Okay, so before coming to this method, I will first give you some idea of what I'm going to explain. So let's say you have a main method. Generally when you write a project, okay, and this main method is responsible to call 3 REST endpoint. Okay, API 1, API 2 and API 3. Right, there's 3 API. Now when you call this API in the sequential way, what will happen? First this call will go, it will finish, then again this call will go, finish, and then this call will go and finish. Right, so you are actually, it will take a lot of time to finish all this API. So performance wise it is going to be very bad, and you know that these days performance number matters. Okay, so how to solve that? To solve that, we have to make all this call in parallel. Okay, we have to make all this REST API call in the parallel. Right, now let's see that how this we can achieve that. So same thing I have just tried to replicate. Let's say this is one API call. Okay, which this is the method which will take your task, and it will take the task, it will print the task, and it will print the current thread name. And here I have a sleep for 2 seconds. Now my second task, okay, here also I have a sleep of 1 second, which is nothing but my next API. My third task, which is my third API, I have a sleep of 900 seconds, milliseconds. Guys, one thing you can see that 2000 milliseconds, 1000 milliseconds and 900 milliseconds. Why I have written like this? There is a reason for that. Now come back. So if you look at, guys, these are my methods. Okay, like let's say for you this is the API, this all three API you have, okay, you need to call this all three API, this three API in the asynchronous way, okay, in the parallel. So if you look at here, what I'm trying to do, CompletableFuture dot run async, I'm calling in the async, and you know that your run async will take of type runnable, okay, it will take a type of runnable. So this is the lambda expressions for the runnable, which I have explained in my previous video. So when you say like this, this will be considered as a runnable, and when you write arrow and then perform task, so whatever you write after runnable, this task will get processed by this asynchronous thread. Right now the second one is like this. So you are saying that when this task is over, then run, okay, there is another method, this CompletableFuture, okay, this future has one more method called then run, okay, this then run method. This then run method, when you press control click on then run, so you look at here, the then run method also will take runnable as an input, okay, and return type is the CompletableFuture of void, so it will not return anything, guys. When you are not planning to return anything, please use this method then run, okay. If you want to return, then there is another method, guys, which I will talk later. So if you look at here, I am saying that then run, and since it requires of type runnable, I am writing one lambda expressions for the runnable, and here I am performing the task, second task, okay, I am calling the second task, okay. Now you can see one more thing. So guys, what will happen here is, here the then run, will it get processed in the asynchronous or synchronous? It will get processed synchronous, it will work in the sync. So once this guy will finish, okay, then only this guy will run, because you are calling the method called then run. So this CompletableFuture has both the method. Let's say if you want to run in the asynchronous, you have asynchronous method. If you don't want to run in the parallel, you have another method called then run methods, because I have dependency here. I want to first finish this, and then I want to run this second task. Then the third one, if you look at here, this is the asynchronous, okay, this task 3 run in the asynchronous way, right. So you will understand the difference also. This guy will run in the sync and this guy will run in the async. Then again you are running one more asynchronous way, okay. So again then run async, when you press control click on this also takes of type runnable, and it also uses the same common fork join pull, okay, when you don't supply. So come back to the example, guys. So this guy will also perform the task, okay. Now one thing we need to understand here is the very basic point. When you have the asynchronous call, okay, when you are running the call in the async, this will be executed in the separate thread by the common fork join pull. Now what will happen to this code? Will this get executed by the common fork join pull? No, this will get executed by the main thread, because this is not asynchronous. Now what will happen to this code? This code will get executed in the common fork join pull, which is the different thread altogether, and this guy will also get executed by the common fork join pull because it's the asynchronous, but this guy will get executed by the main method, okay. And then I'm calling a join, guys, okay. I'm calling the join because I need to wait to complete all this asynchronous call. I need to wait for that, okay, because my few calls are asynchronous. I mean most of the calls are asynchronous, so I need to wait for that. So what I'm trying to do, that is I'm doing that cf.join. This is one way of doing that. There is other way also, which I will tell you. So guys, can I write like cf.join, which I did earlier? Okay, no problem, I can write like this, okay. Just I can write cf.join, okay. This guy will make sure that whatever call, asynchronous call you have made on this CompletableFuture, it will make sure that your entire asynchronous call should get completed, and this will wait for forever, okay. There is no timeout, okay. And then this will get executed by the main thread, okay. Now let's understand why I am printing the thread name here, so that you will understand which task is getting executed by the main thread and which task is getting executed by the common fork join pull thread. Okay, let's run this. This will give you a lot of visibility idea of how it works. So there was a wait of 2 seconds and all that. So now look at guys one interesting thing here. Okay, see here what happened basically. So if you look at here, let me do one thing. So can I this whatever print I am doing that, just wait for 1 second. I will do something. Okay, yeah, that's fine. So if you look at here, your first task is picked up by the common pool worker thread. Okay, this got picked up by the worker thread. Now on the same thread you have then run, okay, which is actually this was the non-synchronous call. Okay, but so one thing I told you wrong, this will get executed by the main thread. No, basically this guy will wait for your first stage to complete. This guy will wait till your first stage will get completed. Okay, and this will also get executed by the same for join pool common pool. Okay, so you can see that even for the second task, right, the same join pool is working on the second task, because you have then run, like once this finish then only run that guys. Okay, now look at the third one. So the third one again on the first completion stage, okay, you are calling that then run async, the task 3. This is the task 3. So the same common pool join will actually will pick up this task and it will execute that. Then the fourth one, then again on the same completable future, okay, you are running the fourth task. So again this guy also will get executed by the same common pool worker thread, right? Why this is happening guys? Okay, why though it is the async call, everything is getting executed by the same common pool. Okay, the reason here is if you look at everything you are calling on this completable future reference on this CF. Okay, if CF, then if this run, okay, like if this complete then run on the same stage. Okay, then again if this complete on the return type of this, then run this in the async. Again when this complete, then again this run in the async. But one thing is common is this is all getting executed by the 4 common pool. Okay, whereas this guy is getting executed by the main thread. Now why you are able to call entire things, okay, whatever you have written here, it is getting printed nicely. You can see that you are able to print because you are calling that cf.join. Okay, you are calling that cf.join. This guy will make sure that your all asynchronous call should get over. Okay, now in next video we will see that what happens when we let's say don't call, okay, don't call this join. So let's say comment this. Now let's not call this, just run it. See here guys, now what happened? So your first task was the asynchronous. Okay, when the first task was asynchronous, by the time your first task was getting over, your main thread execution got over, right? So your main thread came out because main exiting, you can see that your main thread is getting out. So your other task, you don't know what happened. Okay, so always whenever you are calling the method in the asynchronous way, make sure that you are calling the join method. And again, let's say if you have a requirement where you want to wait for certain time, yes, we have overloaded method in the join, that will help us. So now you understood what happened when you don't join that call. After this asynchronous call, you don't know what happened to these 3. Okay, because your main will not wait, your main will continue and your main will come out. Only when you call join, it will make sure that your all asynchronous call will get over. Okay, you understood guys? One thing here, one thing we need to understand, in case of this completable future, you have 2 ways of achieving the parallel calls. One, by using your common pool, fork join pool. Okay, the another way is you can write your own executor and you can supply to these methods. So if you go to the run async method, press control, click on run async method, focus on this method. This guy takes runnable. Okay, there is another method, overloaded method guys, which will take executor also, which means if you don't want to use the common join pool, if you want to use your own executor, you can go ahead and you can write your executor. How this is helpful, that we will see later. Here first try to understand how we can achieve this. Okay, that then later we will try to understand how this will function. Okay, now let's say the same piece of code I want to run through my executor. Okay, that's what I have given in the example number 5. So executor service guys, I have created one executor service which has fixed thread pool of 3. Okay, here I have a pool of size 3, which means I am creating a 3 thread which will perform my task, right? Now wherever you have run async method, which I have shown you, right, you have a overloaded method where you can pass the executor. Right? Now when you pass the executor, it will not use the default fork join common pool. It will not use that. Now your CompletableFuture will not use your default fork join common pool. It will use your executor. And again here you have this method async method, then run async, press control, click on this. So this also has a method which will take executor, and there is another overloaded method which will not take the executor. Okay, these two method guys you can focus here. One will take the executor, one will use the common pool, common fork join pool. Okay, now here how this is different is in this example everywhere I am supplying the executor in case of async, right? And then again I don't need to typecast this, I can just do cf.join, which will work fine. Now again the same method guys, so for you it's like 3 API. Okay, even the all API you can run in the parallel also, which I will tell you later. Here let's say I'm just trying to explain you, this is your asynchronous call. Okay, and whatever your future you will get on this, you are calling this run, and on this run whatever future you will get, you will calling this async. This is again asynchronous, and again whatever output will come from this asynchronous, you are calling one more asynchronous call. Okay, that's how it is. Now you are supplying your own executor. Now you know what will happen. In the previous example, all your task was getting processed by your worker thread, which was 9. Okay, if you will go and execute that, there was fork join common pool 9, which was the responsible for executing all your thread. Look at here. Okay, yeah, so you can see that everything is getting executed by the worker 9, and the reason being is why this is happening like this, because we have given thread.sleep. Okay, so it is waiting for some time. Now let's say do one thing, let me don't write, or let me do one thing, let me write very small time, 1 and 1. Right, I have reduced the time now. Now let's see that what will happen. Okay, and I kept the common time for all 3 tasks. See here, it got executed very fast, but everything got executed by the same worker thread 999, right? And then main is coming out because it will wait, because you are calling the join method. Now let's see that example number 5 guys. Here we are passing the executor. Here what will happen, every task will get executed in the separate thread, right? You can see that. See here, thread 1, thread 2 and thread 3. So basically all the task, whatever task you had, it got executed in the separate thread. Okay, that's the difference. So here your all tasks got executed in the separate thread when you supply your own executor. So these are the very basic example guys, because I just wanted you to understand how we can do this. Later we will see that how this actually will help us. Okay, even in case of common fork join pull, how we can achieve the parallel calls. Okay, and how every calls will be done by the separate thread, that everything we'll see that going forward. So here just try to understand how we can write the code. So here you understood, when you write your own executor, this your entire task will get executed into a separate thread. But one thing, if you look at these two tasks got executed, executed in the same thread, because there was the in the second task, okay, I did not supply the executor. So whatever, this first thread will get over and this will pick up the second task. Okay, now here also just keep the same time in all the thread, sleep time. Let's run that now. See here, it came very fast, but again, first two tasks got processed by the thread 1 and then thread 2 and then thread 3, and then main is coming out, right? Clear? Now look at the the next example. What we have here is, so this is I don't think so it is different than what we have seen that. Okay, this is the same task, you can see that the same the thing is, I just changed the reference name, nothing else. Concept wise there is no change here, right? So guys, we understood two things here. One is, let's say you want to make a API call in the asynchronous way, you can use the method runAsync, which will take Runnable as an input, and let's say these are your API. Okay, just for your understanding, right? Second thing, what we understood here is, this runAsync return type is always void. Okay, it will not return anything. Third thing, what we understood is, whenever we have a asynchronous call, okay, we need to call a join method. This join will wait for forever. It will make sure that your all asynchronous call it get over. When you don't do that, you don't know what happened to your asynchronous call. Okay, let's say you want to consume the output, yes, you have to do that. Let's say you have a requirement where you just fire and forget, then you don't call this join. Okay, just call it and forget what happened to that. Okay, but let's say you want to have the output from that, you need to call the join method. The third thing what we learned here is, when you don't pass your executor, okay, when you don't pass your executor, basically your common fork join pull will come to the action, and your asynchronous task will get processed into the different thread altogether. In my next video, I will talk about what method we should use when we want to return. Okay, in these things whatever we learned is, we don't want to return anything. Okay, so we can just call runAsync, which will not return anything, it will return a void. But let's say I have a requirement where I want to have the return type from my API call. Okay, then what should I do? That we'll see that in next video, guys. If you like this video, please like my video and subscribe my channel. Thank you, guys.